Assalamu alaikum student. Today we discuss the topic that is the coherent waves. Coherent waves, first we discussed about the light. We know that light is an electromagnetic waves. We consider that light is traveling from left to right as a sinusoidal wave. This wave is known as the sinusoidal wave. This light will have a certain frequency, amplitude and wavelength. Now we discuss the properties of the light wave, that is the frequency, amplitude and wavelength. First, we discuss about the frequency of this light wave. Let's start. We observe that the light is start from this dashes line. We observe the light from this dash line. The wave is moving from left to right. We start counting the number of cycle of our wave passing per unit time. This quantity that we measure, this is now is the frequency that is denoted by f. In this case, we have measured the frequency is that is complete 2 cycle per unit time. In this dot that is complete 1 cycle, and in this dot that is complete 2 cycle. So the frequency of the wave is the 2 cycle per second. So we measure the frequency is hertz. So its frequency is 2 hertz. We also define it definition. What is the definition? Number of cycle of a wave that pass through a fixed point. Number of cycle of a wave that pass through a fixed point per unit time is known as frequency of the wave. Okay, now think about our light in a slightly different way. Part of the electromagnetic wave is displaced either upward or either downward relative to the dotted line that we draw here. So that the distance between the dotted line and the maximum displacement of our wave is known as the amplitude. So here we write the maximum displacement from the dotted line is known as the amplitude. So in other words, we can define the amplitude is the maximum displacement of an oscillating point along a wave. So this is the maximum displacement of oscillating point from the dotted line is known as the amplitude. And finally, there is a third property that we can measure is the distance covered by the one complete cycle of the wave. In this case, the distance between the two adjacent equivalent point along the wave, that is known as the wavelength. Here we can also measure the distance between the two equal points in the lower side. That distance is measured in wavelength. So this distance covered by one complete cycle of the wave is known as wavelength, which is denoted by lambda. So here we write the distance. What is the wavelength? So here what we write the definition of the wavelength. The distance is covered by one complete cycle of the wave is known as wavelength. So distance covered by one complete cycle of the wave is known as wavelength. It is all about the three properties of the wave that we discussed before we discuss about the coherent waves. Assalamu alaikum student. Today we discuss the coherent wave. In coherent wave, we discuss the phase of a wave. What is the phase of a wave? Phase of a wave is a measure of how far through a cycle the wave is at a particular point in space. We know that the sine curve is like that. If we start the sine curve by building on the x-axis, where this is the x-axis and this is the y-axis. Now here we plot the curve y is equal to sine of x. This means that what we have drawn here is sinusoidal curve because it looks like a sine curve. We have drawn here one complete cycle of sine curve of on our graph. Let's start by recalling the value of x, that is 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. This value is handy for us when we define the phase of the electromagnetic wave. So we know that in the sine curve, the value of x, if 0 degree, then a graph is 0, sine is equal to 0, sine curve is minimum position. When the value of x is 90 degree, so we graph obtain, we get the maximum value of the sine, that is the sine 90 is equal to 1. So we get the maximum position at this point. When we take the value of x is 180 degree, then again it becomes 0. When the value of x is 270 degree, then it maximum in the negative position, and 360 degree, the value of x is again 0. Now the electromagnetic waves are periodic, which says that they have a repeating pattern. If we can define this point also has a 0 degree once again or 360 degree. In 0 degree, we again start the cycle, that is here it is 0 degree, this is the 90 degree, this is the 180 degree, this again the 270 degree and 360 degree, and this is the complete way of the determine the phase of a wave in a repeating pattern. So this wave, this electromagnetic wave, which we define the phase of a wave, we can compare this phase by the sine curve. In this minimum position, this phase has a 0 degree value. In this position, the phase has a 90 degree value. In this position, 180 degree, and this position 270 degree, and this is the 360 degree. And this is again repeating the cycle of the wave. And here is again 90 degree, 180 degree, 270 degree, and 360 degree or 0 degree. And we can determine the phase of the wave like this. By comparing these two waves, we find that when the frequency is same, and we find that the phase difference is also between them is 0 degree, or phase is same between these two waves. So these two waves are coherent wave because both have the phase is same and frequency is same. Now we use the concept of the phase of a wave. We compare the two waves. For compare the two waves, we know that these two waves have the same number of cycles. So they complete the two cycle in a particular time. So they have the same frequency of both of the wave. When we compare this wave with a sine curve, that is the like this is the sine curve. If we compare the value with this sine curve, we know that this phase is 90 degree and this is the 90 degree, and this phase is come down from this point. So this become the 270 degree that we discussed here. So this point also become 270 degree, and this point is also become 270 degree, and this point, this wave is go from down to up. So this is point becomes 0 degree, and this point is again become 90 degree. So here we define also this is the 0 degree and this is the 270 degree, and this point is 360 degree or 0 degree. This point is 90 degree and this point is 180 degree. If this point is 0 degree and this point is also become 0 degree, and this is the 90 degree, and again here become 180 degree, and this point also become 180 degree. So in this wave, in both of the wave, we define the phase of the two wave is equal in each point when we compare the waves of phase of the wave with the sine curve. So if we find the phase of the wave at the particular point at this position, let's say this phase of the wave at this point is defined by phi subscript 1, and the phase of this point is defined by phi of subscript 2. So we can define the phase difference minus the phase difference of phi 2 minus phi 1. At this point, the phase difference is 180 degree, and this point the phase difference is 180 degree. So it is equal to 0 degree. In this way, we can find the phase of the wave by comparing the two waves. This is all about the phase of a wave. Here we define these two waves are coherent. If let's compare these two waves with the sine axis with the sine curve, that is the y is equal to sine of x. In the sine curve, in this here the value of x is 0 degree, here 90 degree, here is 180 degree, here is 270 degree, and this is here is 360 degree or 0 degree. This in this case, the phase of the wave compared with the sine curve. At this point, the value of the sine curve is 90 degree is go up from the down. So here the 90 degree, if we compare this wave with the sine curve, we also get here the phase difference is 90 degree. At this particular point, the phase of the wave is compared with this sine curve, that here the value of the curve is 0 degree or 360 degree, and here is also 360 degree. So if we find the phase difference, let we define this point is the phi 1 and this point is phi 2, and this point the phase difference is phi 1, at this point the phase difference is phi 2. If we find the phase difference between these 2 points, phase difference between these 2 points is found by phi 2 minus phi 1. Here phi 2 is 90 degree, phi 1 is 90 degree, so it is equal to 0 degree. If we find the phase difference here is phi 2 minus phi 1, phi 2 is 360 degree and phi 1 is 360 degree, so it is equal to 0 degree. So in the both wave, the frequency is same, frequency is same, both of the wave and phase difference is 0 degree. So for what we write in definition, if phase difference is 0 degree and frequency is same, so these both waves are coherent waves. Now we compare the phase difference of these two waves. If we compare these two waves with the sine curve, so here the sine curve, the s value is 90 degree, so here the phase difference is the 90 degree. In this case, the phase difference phi 2 is, it go from up to down, so here is the value is to 70 degree, and this particular point the phase difference is go up down to up, so is here the value is 90 degree, and here the value is go down to up, to here the value is 360 degree. If we calculate the phase difference, here is the phi 1 and this is the phi 2. Phase difference between these two points is phi 2 minus phi 1 is, and here phi 1 is 90 degree, so what we get is phase difference is 180 degree. If we calculate the phase difference between these two points is, that is equal to phi 2 minus phi 1. Phi 2 here is 360 degree and here is 90 degree, so it is also equal to, so here the phase difference is 270 degree. In this case, the phase difference is not constant. Here is 180 degree and 270 degree value is not constant. If the value is not constant, so these both waves are in coherent waves because the value is not constant.